Hi, welcome to Cooking with Photo and Synthesis. I'm Photo.
And I'm Synthesis. We got a great show for you today. We're making one of my personal favorites, glucose.
Ooh. You will need carbon dioxide,
Sunlight,
chlorophyll,
hydrogen ions from its surroundings,
and water.
Let's get cooking. For the first step in our process, or photosystem 2, you will need a pot, some chlorophyll, and electrons. So you add the chlorophyll and the electrons, just like that, and then we'll turn on the sunlight. Now, we'll gently stir the electrons, and as they become excited by the sunlight, they'll begin to jump up energy levels. And now you can hear the electrons starting to get excited. They'll start popping up energy levels. Let's take a peek. Look at that.
Now we will begin the process of water photolysis using sunlight. We'll break the bonds of the water and create hydrogen ions and oxygen. Now the oxygen is released into the air.
And now we take these excited electrons down the electron transport chain, in the process bringing hydrogen ions to the lumen. Now for photosystem 1, we will do the exact same thing as photosystem 2. All you need is some chlorophyll and some electrons to be excited. We'll add the sunlight, and off we go. And now we have even more excited electrons.
And now we go down the ETC again with the excited electrons. Now we move the excited electrons down the ETC into the NADP positive reductase. And there you have it.
And now we're going to take the hydrogen ions from outside, electrons, and NADP positive, and put it into the NADP positive reductase to sit. And now let's go check on it.
Would you look at that? Lovely.
This is just going to turn out great. So over the course of this cooking process, we've slowly been gathering hydrogen ions in the lumen.
So the concentration of hydrogen ions is greater in the lumen than the outside.
That equals energy. So let's put it into the ATP synthase and see what happens.
And now we'll check out what's happening in the ATP synthase.
And would you look at that, we have some nice, beautiful ATP right there. And now we'll take our ATP
NADPH,
and carbon dioxide from the air and put it into the Calvin cycle.
or the light-independent reaction.
and we'll put it on for a couple cycles. This is the Calvin cycle, where we start off with Ruby P, which is a 5x3 carbon arrangement, add CO2 to make it a 6x3 carbon arrangement in carbon fixation.
Then ATP is added to rearrange it into a 3x6 carbon arrangement.
In reduction, NADPH is added to break off carbon to make G3P, which is made of 3 carbon atoms.
More ATP is then added to rearrange the carbon to make Ruby P in regeneration.
2 G3P makes 1 glucose. And 6 cycles later, let's see what we have.
Oh, look at that beautiful glucose right there.
Just lovely.
Oh, smells so good. Just can't wait to eat it. Whew.
It's gonna be amazing. And this is cellular respiration. Let's go. Thank you for joining us
on Cooking with Photo
and Synthesis.
Have a nice day.